In augmented reality, gesture and hand-based interactions are becoming more common than tangible user interfaces and physical controllers. For tangible controllers to be usable on the go, they need to be low energy and portable. We began to explore powerless transformable controllers inspired by opportunistic controls, utilizing computer vision readily available in modern AR head-mounted displays to address this concern. After many iterations, we designed an AR marker-based controller which can be fabricated by a 3D printer or on paper. Our high-fidelity prototype was composed of TPU flexible material with ABS material for the markers. Combining these two materials allowed us to experiment with novel interaction modalities, such as wrapping and folding. In addition, we experimented with low-fidelity cutouts of the controller, which allowed us to experiment with the form of it, however being less well built. Tracking was achieved by using AR UCO and OpenCV in Unity. We ideated 6 interactions usable for the controller, such as folding, wrapping, accordion, attachment, movement, and rotation. Folding consists of folding the controller face over face, as well as closing and opening. These affordances were modeled and inspired by interactions with paper fortune tellers and book interactions. In addition, this interaction can act as a multi-value switch and as a pointer. The next interaction, wrapping, involves wrapping and unwrapping the Velcro of the controller to change the object's form into a cube or to wrap around the volume of an object. By wrapping, we were inspired by the concept of symbiosis, where wrapping enabled the controller to inherit the affordance of the wrapped object. For example, a door handle inheriting push and pull, or a coffee cup lift and pour. Accordion involves compressing the controller via a level of force whilst the controller is in a zigzag pose. This provides a slider-like function to the device. We were inspired by the affordances of a mechanical spring, such as compression and decompression. Attachment refers to the affordance of attaching the controller to metal surfaces using magnets on the interior of the object, while in a wrapped or unwrapped pose. The next interaction, movement, just refers to merely moving the controller in space, and rotation simply reorienting the controller into different rotations. We show the feasibility of the different interaction modalities in the following table as an on-body, on-object, and standalone controller, based on our experiences with the device. By on-body, we are referring to the controller being wrapped around the arm or on the body, on-object wrapped or attached to an object, and standalone just like a regular controller in your hands. We imagine a number of use cases, such as tangible cups, where an everyday object becomes a tangible interface that you can stamp and rotate, drawing and erasing digital content on a whiteboard, physical sliders, and standalone while in the field, such as performing transform operations on a virtual building while it's being designed. Despite these use cases, there are limitations, such as having to have the controller in view of the HMD's camera or cameras in order to detect operations. In addition, occlusion behind other objects. Potential solutions to this problem includes embedding electronics into such a device, such that it can transition from a passive to an active device when out of frustum, potentially using bend sensors and electronic buttons. To summarize, we presented a work-in-progress novel passive interaction tool that can be used opportunistically with everyday objects. In addition, we presented potential interaction modalities, standalone or in sync with an everyday object. Potential future directions could pertain to investigating the potential of a passive to active state switch, markerless based tracking, such that we can track the torque and folding in a similar way to tracking origami. Usability also remains to be a concern in respect to the different fields that are applicable for such a device, and how it could actually benefit over gesture hand-based input and traditional controllers, as well as future ideation to explore additional interactions and use cases. Thank you for listening. Please read our paper for more details.